So hi, in this video I'm going to find the domain of two variables functions. So I have three examples of two variables functions. So the first question is natural log of x plus y minus 1. So for the first questions, basically you need to know what's the restriction on a natural log. So whatever on the inside of a natural log, that has to be something positive. So our domain will be the set of x and y coordinates that satisfy x plus y minus 1 is greater than 0. So you can get y coordinates greater than negative x plus 1. So if we sketch the graph, we will get this graph. So well, the negative x plus 1, that's a line that goes through the y-intercept of 1, has a slope of negative 1, and since y has to be strictly greater than that, we use a little dash line, and the domain would be the set of x and y coordinates above that line, which is this. So the answer, the domain is curly bracket x, y, which is y is greater than negative x plus 1. So the next example is this, which is, the question is square root of y minus x squared over 1 minus x squared. So we know the stuff under the square root has to be greater than or equal to 0. So this is one of the relationship we will have to satisfy, and another relationship that we have to satisfy is, we don't want the denominator to equal 0, so we will figure out where it does equal 0, and we will throw out those particular values. So if you take the first inequality, you will simply get y is greater than equal to x squared. But if we solve the second equation, either factor it or just do the square root of each side, we will get x equal to positive or negative 1. So we need the first one to happen, but we have to exclude this value. So basically this is the sketch graph for the domain of this function. So we need to exclude this. So basically this is the domain of the function says that y has to be greater than or equal to x squared. So this is the graph of equation y equal to x squared. So actually we have to leave out the values of x equal to positive 1 and x equal to negative 1. So here is negative 1 and here is 1. So we have to leave those values out of the domain, which is here. So when y is greater or equal to x values on this curve, well, that's going to be on the interior side of the part above y equal to x squared, and again we have to leave out the x equal to -1, but all the other values here that I am shading that I am shading here, that will be the domain of the function. So the domain of the function is x, y. Y is greater and or equal to x squared. So let's move to third example. So the question is ln 9 minus x squared minus 9y squared. So here's the solution. Well, first of all, we need 9 minus x squared minus 9y squared is greater than 0 because of the restriction of natural log, where inside of natural log must be positive. So this is equivalently would be 9 is greater than x squared plus 9y squared. So let's try to draw these on the xy axis. So let's sketch the graph. So x squared plus 9y squared equal to 9 would get an ellipse. So if my y values is 0 and my x could vary from -3 to 3, and then if my x value is 0, then my y values could vary from +1 to -1. So essentially the ellipse I get will look like this. So this set of points that satisfy my x squared plus 9y squared is less than 9 are actually all the points inside this ellipse, but not touching the boundary, which is this dashed line, because they don't have equality here. So essentially all the points satisfying inside the ellipse, and this is the domain here. So the final answer is the domain is xy, which is x squared plus 9y squared is less than 9, curly bracket, which is correspond to into the interior of this ellipse. So that's all for this video. Thank you.